All right, this is lesson 8.1, and it is in our new unit 8 that is all about ratios, rates, and proportionality. If you look forward in your packet, you will see that all of the things that we're looking at, better buy, faster reader, these are applications to everyday life. The rate of sit-ups, dollars per pizza. These are things that you will do in everyday life. So this unit will have everything to do with your everyday life. If you haven't seen connections before, you will definitely see it in this unit. If you haven't already completed your vocabulary, please do that. Here is what it should look like, with ratio and rate and unit rate being the first things that we're going to talk about, and then later we'll go into proportions, constant of proportionality, and direct variation. So be sure to have examples for each, and in each lesson we'll go into greater depth for each of those. Now if you turn ahead to the next page, this is what our notes will be for today. Starting with a ratio versus a rate. These are two different things that are very similar. A ratio is a comparison of numbers by division. So please write in comparison. Ratios show the relationship that exists between two quantities. Ratios can be written in three ways. It could be written with a colon, 2 to 5. It could be written as a fraction, and this is what you'll most commonly see ratios as. Or it could be written with words, 2 to 5. Ratio tables are very helpful to be able to organize equivalent ratios. And you'll notice that these are very similar to fractions. Ratios are basically like a fraction, but it can be thought of in a little bit different way at times. For example, we would never talk about cats and dogs together as a fraction, but with a ratio we would. We'd talk about 5 cats to 4 dogs. And if we were to extend that ratio of 5 to 4, we can talk about 10 cats being to 8 dogs, or 15 to 12. And notice on the top here, we're going by 5s. You're going to add 5 every time. With a ratio, it's important to keep the relationship constant between these. So 4, you're going to add 4 to get this new ratio and do the same with each. So we'll have 16 and 20. Go ahead and try the apples to oranges. Again, not something we would do with a fraction, but 2/3 in and of itself you can think of like a fraction, and then it's easier to determine what will go right here. So if we go on the top by 2s, you should have filled out that this would be 4, 6, 8, and 10, and on the bottom we would go by 3s. So 3, 6, 9, 12, and 15. My apologies that my writing isn't in the boxes. This is much smaller than what you have on your page, so I hope you can do better at doing that. If we look at boys to girls, like for example in a classroom, let's say we have 35 people and 20 of them are boys and 15 of them are girls. We could work backwards to figure out what the ratio is. So for example, this one right here, if I go backwards here, I've got 1, 2, 3, 4 boxes. If I think of dividing by 4, I might see that we would probably start with a 4, or I'm sorry, there are 5 boxes, so we have to divide by 5. If I went by this one being 4, 8, 12, and 16, you can see that it works. If we had tried going instead by 4s, then it wouldn't have worked. This would have been 20. I'm sorry, going by 5s. Ooh, I'm making mistakes this morning. My apologies. If I went by 5s, we would see that it wouldn't work. We'd have this extra space here. So you definitely want to be careful that the relationship works, and it's a little trickier to start at the end, but you can still do it. So again, if I think of this was dividing by 5, and this is dividing by 5, then I can think back that this is definitely going to be a 3, and I'm going to go by 3s. Can you see a connection with probability here? These fractions, equivalent fractions, are much like probabilities. All right, looking at rates. Rates are a little bit different, but they still compare quantities. Okay, except in this case, a rate is a ratio that compares specifically two quantities with different units of measure. So really the units are what give away that you have a rate versus a ratio. Rates are typically described using per. For example, $7 per hour is a rate. 55 miles per hour. Notice the per again. $50 per sweatshirt. Or you might have 9 points per 3 minutes. Also notice a lot of these are with time, but definitely doesn't have to be. A unit rate is a specific type of rate. So we've got all these rates that have per something, dollars per hour, miles per hour. And a unit rate is basically per one. So a lot of these that we have up here are unit rates. Notice that $7 per 1 hour, that's per one, so it's a unit rate. 55 miles per hour, again, per one. If it doesn't say it, you know that it's got a 1. $50 per sweatshirt, that's again per one. But this one, the 9 points per 3 minutes, that is not a unit rate. So again, the denominator of a unit rate is always 1. Sorry, I changed colors. So sometimes you'll be asked to find the unit rate, and this can be very helpful for solving problems. If you scored 84 points in 6 games, right now this is a rate, but if we change it into being per one, we'll see that it will be a unit rate. So 84 points per 6 games equals, and all we have to do to find the unit rate is really just divide. So do 84 divided by 6, and you can do that on a calculator. You see that 6 goes in 8 one time, and 24 4 times, which means I have 14. But please don't leave it like that. Remember, a rate has to have units, and a unit rate specifically has to be per one. So you have to write 14 points per one game. And that would be your unit rate. The next one, you can type 150 words in 5 minutes. So write it as a fraction, but remember it's a rate because it's got units, those words, okay, equals. To find the unit rate, just divide. 150 divided by 5, yay, I can do that in my head. 30 words per 1 game, or 1 minute, sorry. That is our unit rate. It's a unit rate because it has a 1 in the denominator. And lastly, $3.98. This one I use a lot. $3.98 per 12 cans because Pop always has different prices at different places. So it's important to figure out how much it would be per 1 can. And that's a unit rate. Again, you do that by dividing. So $3.98 divided by 12, you definitely want to do this on a calculator. You'll see that you get a big long decimal, and it's even a repetand. So it ends up giving you 0.3316 repetand. And don't forget the dollar sign. In order to be a rate, it has to have the units, dollars per 1 can. So you may think, well, why would I put the extra decimal points? And the reason is because these can get really close. But as you buy more and more of something, for example, diapers, you will see that the cost adds up, and you want to use those extra dollars. The other way to write a unit rate for this problem would be just to leave it $3.98 per 1 12th pack. Okay, so checking up, just make sure you have your notes. If you can't read anything, please press pause. And going to the next slide, ratios versus rates again, we can use ratio tables. I'll talk to you in a little bit. We can use these to find equivalent ratios. And it's really great to line them up in a table because that's what you're familiar with. So for each of these, just write down the 2 things that are given in the problem. This recipe calls for 2 eggs for every 3 cups of flour. And this is a place when you definitely see ratios a lot. Next, we've got 2 to 3, it says, and we can fill in each of these other numbers. Okay, so go ahead and continue your writing in, and you'll see many equivalent ratios. For each of these, you can go ahead and put in the 2 different things that you're comparing. In this one, the probability of drawing a heart. So maybe hearts out of the total. And do you see how this connects with probability now? We've got 13 out of 52. And we can continue to see how much that would be if we double each of them. And then continuing up, you can just see if I get multiple decks of cards, what's going to happen. So please fill in the rest of these and we can check them later. The very last one, I'm going to jump to, in order to get a perfect shade of pink, you add 1 drop of white for every 3 of red. So number of white and number of red. Can you see how this will make it very easy to do ratios? And it's asking what should you add when the mixture contains 36 drops. So you can continue working up, or you can even multiply these by 3 to get to 36. So we know that it should be 12 drops. Going back to the rates, these are unit rates again. So similar to what you did on the last page. Please complete this for your class notes today and check with the answer key. So today we've talked about ratios versus rates. Just a reminder, a ratio compares 2 numbers by division. It could even have 3 numbers by division. A rate compares them but has different units of measure. All right, happy mathing.